There's an email from LNS Technologies. They're working on a new injection molding machine and wondering if I'm interested in making an injection mold for the Craftsman. If he's in, I'm in. And let's see. Oh yeah, here's the reply. Let's see what he says. The Craftsman's in. We're a go. Let's get started. As I mentioned in the intro, LNS Technologies reached out to me to do a collaboration between me, them, and the Craftsman, which I thought was very cool. He reached out to me to ask me to make the mold, and then he's sending the Craftsman one of his new injection molding machines. And by the time this video drops, I'll put a link up above, but there will be a video from him as well, using the molds that I'm making in this video to actually make some Pocketnauts. So what is the Pocketnaut? Okay, there's a card up above that is a link to his video on the Pocketnaut. And here's a picture as well, but basically it's a small figure, I guess an action figure, I'm not sure what you would call it. And it's made out of TPE, and then it has a face insert that is going to be made out of a more solid plastic, a stiffer plastic. And I'm going to cover that second mold in part 2 of this 2-part series. So how did I end up getting involved in this? The way I got involved is he's had, the Craftsman that is, other people make molds for him in the past. This one though turned out to be trickier. It was more complicated. Let me show you why it was more complicated, and then I'll go through the process of making the molds and show you the whole process all the way through using this machine to test the molds before I send the molds off to him. This is the file that the Craftsman sent me for the main body of the Pocketnaut. And there's a challenge, which is this area right here. Let me show you where I started with the mold design, which is right here. And again, it's this area right here. If I do cross-section analysis of that, then it becomes pretty clear what the problem is. When we're using an end mill, it cuts straight down, and so there isn't a way to cut this area here. So I thought about a few different approaches on how to deal with this, and the first approach that I came up with is to use something called a lollipop mill. So I went to Harvey Tool, and they have this page that shows the different profiles, and if I scroll down, you can see that they have undercutting end mills, which is exactly what I wanted. The difference between these undercutting end mills is how far they can undercut. So you can see this is just a small amount, and then 300 degrees is where this wraps around 300 degrees. So this is the one that I wanted to use. And I don't need a reduced shank because that'll reduce the strength of the end mill, make it easier to break it. So I went with this one, and down here, after doing some calculations, I settled on this one right here, which you can see has a cutter diameter of 3/64 of an inch and a neck of 18 thousandths of an inch, which means it's going to be pretty fragile. And to look at that possibility, I modeled, as you can see here, let me rotate that around. You can see this coming straight down, and it's just barely touching that area and not quite cutting this area here. So I thought about it for a little while and did some research, and then decided to take a different approach. The approach I decided to take is to make an insert, which is the part here that is a different color from the rest of the mold. The idea of an insert is I can mill the underside of this separately, as well as the locating feature for the insert, and then have this be a press fit. This is showing a cross-section so you can see that it doesn't go all the way to the bottom. It doesn't need to. If I turn off the section analysis, this will give you a better idea of what that looks like, and let me pull this out. And you can see it has this shape here. Now the reason it has that shape is so that it won't rotate. You can see that's the purpose of this. And then it has different radii here to make both sides easy to mill with the end mills that I have. Now I actually made one other change to this. Let me go to the end here, which is this section here is actually slightly smaller than the rest of this. And the idea is that this part here is going to be an interference fit. That means it will be something I have to press in with an arbor press, because this is going to be slightly larger than the hole, and so it'll require force to push it in, but that will also keep it from coming out. And so the idea of this section here is to be smaller to provide the initial alignment to get it started. I start out with a piece of bar stock of aluminum that I cut to approximate length, and then I've already finished it to the exact width. What I'm doing here is I'm picking up the approximate back left corner, which is the location I use as a reference point. So I can put this back into the machine and get it exactly in the same position if I need to make any changes. So here it's running the actual probing to find the exact position, whereas what I had before was the approximate position of the back left corner. The camera here is actually looking from the right to the left, which is why the back left corner actually looks like the back right in this video. Next, my machine changes tools. It's switching to a 2-inch diameter end mill that I use to deck off the top so that I get a nice smooth finish all the way across. This is spot drilling the two locations where I'm going to drill holes, which I am doing in this step here. And then after drilling the holes all the way through, then I come back with an end mill to cut these to the correct size for some alignment pins that I will put in here, that I use to make sure that the two mold halves are in perfect alignment. Next, I use the same tool to remove the bulk of the material. This is called a roughing operation. And this takes quite a few passes to work its way down. First it has to cut to depth, and then it starts to more aggressively cut out from the original location where it was cutting to depth. And then, here's the very end of the roughing operation, so it's just finishing up the very bottom. And now it's changing to the next tool, which is a much smaller tool. One of the things I love about this machine is it has room for 20 different tools. And so I don't have to constantly change tools. The machine does that for me. Switching to the smaller diameter end mill allows me to reach areas that I couldn't reach with the larger diameter. In other words, in corners, etc., where the radius just was too large to be able to get in there. And this is called rest machining. If you look closely, you might be able to see this stair-stepping of the end results. And so now this is switching to a different tool. The previous operations were all done with flat end mills. This is being done with a ball nose end mill, which means it's rounded at the bottom. And therefore, if I go around like you see it doing here, and step down a little bit at a time, it produces a very smooth finish on 3D curved surfaces. After milling this, you can see there are some marks here. Now these marks, the round ones, I think are not a problem because I believe they're less than 1/10,000th of an inch tall, and I can't feel them with the tweezers. But these marks here, I can see them more clearly, and I can also definitely see them with the tweezers. These are a result of the strategy that I chose, so I'm going to put it back in the machine and redo these areas as well as some other areas like here and at the base there. And then that should make it clean enough so that when I injection mold the part, it'll come out very clean. Here I'm centering the mold back into the vise, and the reason I'm centering it is so that when I come back with the probe, I don't have to pick up the rough back left corner. It already knows that position. And so this is an example of how I can put the mold back into the machine and very precisely locate it. I'm using a probe, but you can also use something like an edge finder, a hammer, or some other way to pick up the edge. This is coming back with a 1/32 inch diameter ball end mill to just clean up those areas that I was pointing to with the tweezers. It's using a slightly different strategy, so it's producing smoother results. You can see it's actually going straight across here, whereas before it was kind of going up and down. This is showing the before and after, with the before on the top. And you can see how the ridges that are in the trough around the head are much cleaner in the one below. Now we get to the more challenging part, which is to mill this half that has, let me hide this piece here. So it's going to have a pocket where we press fit the insert. This part is fairly straightforward. The more interesting part is milling the insert. And so I decided to start by milling the insert first. The idea is that if I mill the insert first, the dimensions here will be whatever they turn out to be. But if I go back to the core and mill the second, I can adjust the size of this as needed to make sure I have the right fit for the insert. So let's take a look at how I approached milling the insert. So I'll show that again, and then I'm going to hide the core itself. And then what I did is I created some stock. And so the idea is that I'm going to have some round stock. You'll see how I get that in a minute, where what I'm going to do is I'm going to mill from this side. Now to make that work, I decided to use something that's known as window milling. The idea of window milling is that I'm starting with a rectangular piece, as you can see here, and then what I'm doing is I'm milling out inside along with some tabs. This is kind of the window, where you have the window frame is the idea here. And so I can mill first from this side, and then once I've finished milling from that side, I will mill the other side, which produces the tabs here, and then I can break these off, so I'll end up with, let me hide the frame, so I'll end up with a piece that looks like this, with a few vestiges of tabs when I'm all finished. And then I can press this into the other half of the mold, and then mill this side as the final operation. I started with a piece of rough cut stock, and you can see the end toward the camera is still raw. It doesn't need to be cleaned up, so first I'm finding the approximate edge, and then I run the cycle, which picks up the exact back left edge of the part. Then I'm surfacing the top. I don't really need a smooth finish like this, but it does ensure that I have the correct Z height when I flip the part over. Unfortunately, the camera image is not clear because I forgot to turn on the air blast, which keeps the face of the camera clear. The coolant is splashing onto it, so I need air to blow it away. So this is starting out roughing out most of the material. And then once it finishes roughing the material, I come back with a smaller end mill to cut out some of the details that were smaller than the large end mill could cut. And then switching to a 1/16 inch diameter flat end mill to cut the outside of the part that's going to be the press fit. I want this to be very precise, and some of the radiuses are fairly small, so I had to switch to this smaller end mill to be able to cut it accurately and completely. Now that the profile of the section that is going to be a press fit is finished, I come back with a 1/16 inch diameter ball end mill to cut a lot of the material away for the curved surface that's going to be in the undercut. This does not completely cut all the material, so I need to come back with an even smaller 1/32 inch very long reach ball end mill to clean up the rest of the material. I flipped the material over and then picked up the back right corner. The camera is now looking into the machine from the front, so it's oriented the same way as I'm describing it, and then started milling this out. And the reason I picked up the right corner is because it's the left corner when it was flipped over 180 degrees, and this gives me the best alignment. This is removing most of the material from the back side. Now it's actually going around, so there's the round slug that's protruding up from the back side. And here it's starting to mill the window openings, which is the open part in between the tabs. And you can see it's pretty much finished that, and now what it's doing is it's thinning the tabs. I ran that pass a little bit more aggressively than I intended to, so it's a little bit rough for the finish, but these should be just 0.3 thousandths for the tabs, which means I should be able to just, as you can see, cut them quite easily with a knife. And there we go. I have my insert. I'm going to go, I think, use sandpaper or file to get rid of these tabs, just so it's not so sharp. Milling the core side is pretty much the same as milling the other side, which was the cavity. The only difference here is that this is a different view than from before. This is through the front of the machine rather than inside from the side of the machine. It's roughing out the material in this shot here, and it's using something called trochoidal milling or high-speed machining, where it's taking what's supposed to be about the same amount of cut each time. Switching again to a smaller end mill, this is going back and removing some of the detail that I wasn't able to remove with the slightly larger end mill. This is a good shot showing an example of where it's removing material that could not be removed with the previous end mill because it was too large to fit into this area. This mold is pretty much all curves, so here I'm using a 1/16 inch diameter ball end mill to smooth out the majority of the curves, and this is working its way down slowly and smoothing more and more of the area. And finally, the very long reach 1/32 inch ball end mill to cut all of the really fine fillets that are inside this mold. So I don't know if this is going to go in. Probably not, because I do want it to be a little bit of a press fit. Nope, it doesn't. Now, it feels like it might press in, but I want to make sure. So first thing I want to do is measure this with a gauge pen. And I'm going to start with a little bit less than 0.3 because the target is 0.3. So let me go to my gauge pins and find one that is a little bit less. Okay, here's one that's 299. 299 is loose. 0.3 is, it fits in. Let me try 0.301. Okay, so it does not go in. So that means that this is actually right on target. It's supposed to be 0.3, and it is. Now let me see if I can measure this. And the battery on my micrometer died, and I don't have any spares right now, so I'm going to do it the old-fashioned way, which is to use the scale, the analog scale. Okay, so looking at this, it says it's 0.302, so that seems to indicate that this should be a press fit. I'm going to measure it off screen a few more times, but if it's a press fit, then I'll just go to the arbor press and press this in. Yeah, it's coming in about 1/1000ths over, so that should be a good press fit. What I'm going to do is set up the arbor press and cross my fingers. I mean, the worst thing that will happen is that I'll have to remake this mold, which is not a big deal because I've figured out all the cams, so it's just a matter of pressing, cutting out the blank, then setting it to the right width, and then pressing go, and it goes from there. Okay, I'm going to be brave, or stupid, not sure which yet, and put this in there. And that worked perfectly. I was watching the gap and watching it go away, and just came out perfect. So now I can put this back into the mill and then mill the top side, and then I'll be able to test the mold. And then back in the machine one final time, picking up the back left corner, which will mean that we know exactly where it's located. And then we can start milling away the cylindrical part of the insert that we don't need anymore. Once we rough that away, then we can come back with the ball end mill to slowly clean it up. First cleaning up the top and then moving slowly down to lower and lower portions. I don't have one of the new LNS machines, and I did try the mold on my other machines, but they were not able to fill enough plastic into the mold to fill the mold, which is called shot size. So the shot size was too small, and therefore it was called what's known as a short shot. This machine has plenty of capacity, so it has no problems filling the mold, which is why I'm using this machine. This machine is designed to handle much larger molds. So I have a bunch of aluminum blocks here to fill up the extra space and to jack it up a little bit so that it's the right height and distance below the nozzle. So that's why you're going to see me using this machine today. Now for the plastic, I'm using, and I already have used some of this, TPE that I got from LNS as well. It's orange TPE. This is what I got initially, and I didn't purge my machine thoroughly enough from the previous plastic. Basically, the way that works is I had a different plastic in there, and then I initially started out by using some clear plastic to try to clear it out, and you can probably see some streaks in there. That's the even older plastic that I'm trying to get out. And then it slowly switched over to the new plastic that I put in there, and I ended up using most of the plastic. So LNS was kind enough to send me a larger container, which I've just barely scratched the surface on, because I wanted to get this mold sent off to the Craftsman sooner, so I was under a bit of a deadline. So I did a purge on this, and I'm still getting some streaking from the previous material. It's getting better, but I want to get the mold sent off to the Craftsman, so I'm not going to finish the purging. But you can see it molds quite easily, and it comes out quite nicely, even though there is this undercut that's in there, because this is flexible. Now it's still warm, and so it won't be quite so flexible when it's cool. This is one that's cool, but it's still, you can see, quite flexible. Here's a little bit of a sneak peek of the next episode. You can see that there's a face in here now. Let's see if I can get you a close-up with the camera. So you can see there's the figure and the face in it. And the face is going to be what I'm going to be machining in the next episode, and I'll show you the injection molding of that. This project was really a lot of fun. It's the first time that I used a pressed-in insert, and it turned out perfect. I'm really happy with how it turned out, and the Craftsman seems to be really happy as well. It was a great collaboration, a whole lot of fun, and so I am just so happy with how things turned out. I hope you enjoyed this video as much as I enjoyed making it. I'd like to thank my Patreon supporters or patrons, they're listed here, for helping to support this channel. Also, please help me grow the channel by subscribing. If you subscribe, which you should, so that you can see part 2. Also click on the bell icon so that you're notified when my next episode drops. Also comment below, give me a thumbs up, and again, thanks for watching, and I'll see you next time.